Hello students. We continue same chapter, that is the solution, and the next topic is that vapor pressure of liquid solution. Okay, vapor pressure of liquid solution, and you know that we study about binary solution, and binary solution means one of the two components involved in this solution. First is the solute, here the solute, and second is the solvent. Solute and solvents makes its liquid solution, and solute particles, it may be the gas, liquid and solid. Solvent is only the liquid, and formed solution is called the liquid solution, and this liquid solution is called the binary solution. Okay, again look at here. Solute may be the gas, solute may be the liquid, solute may be the solid, and solvent is compulsorily liquid. And when the solute like this state of matter dissolve in solvent, okay, and form the solution, and that solution is called the liquid solution. Again we discuss only we study in this chapter two types of solution, liquid solution, and liquid solution is formed when the solute component is liquid and solvent component is also liquid form, liquid state, and the obtained the solution is liquid solution. Okay, and this total phenomena is called the liquid in liquids. Again second is the solid plus liquid. That means the solute components is solid form and the solvent component is the liquid form. When solid is added in the liquid, and the formed solution is called the liquid solution. Okay, and this is called the solid in liquid. This is called the solid in liquid and solid in liquid. Okay, and next is that and this is the vapor pressure of liquid solution. Again we discuss let two components, and that components is the solute and solvent, and this just be identify this solute is the component first and the solvent is component second, and these two components are the volatile. Volatile means they are vaporized to each other, they are vaporized very easily. Okay, and when the volatile liquids is added in the volatile liquids, which is solvent, and form the binary solution, that is called the liquid solution. Okay, and here you understand, and this is the and these components, you take a closed vessel, and that closed vessel is this closed vessels is formed component 1 and component 2. This is the closed vessel, and because these components are volatile, so the vapor phase or the vapors of these components is apply the pressure of the wall of the container. At last at equilibrium state, let vapor pressure is P total, that is the vapor pressure. Let vapor pressure is P total, and partial pressure is the P1. P1 means this partial pressure of component first, and this P2 the partial pressure of component 2 of component first and second respectively. Okay, and P is the total pressure, vapor pressure. P is the total vapor pressure, and Next one is the partial vapor pressure are also related to the mole fraction. ठीक है, पार्शियल वेपर प्रेशर जो आपका होता है वो किससे रिलेट होता है, मोल फ्रैक्शन, एंड मोल फ्रैक्शन इज डिपेंडेंट बाय द x1 एंड x2 ऑफ द टू कंपोनेंट्स 1 and 2 रिस्पेक्टिवली. राउट्स लॉ ये कहता है, फिर राउट्स लॉ इसी इंक्लूडेड है. उन्होंने क्या बोला कि जो आपका सोल्यूशन volatile, this Raoult's law given his law, only the volatile liquids, solution of the volatile liquids, and the partial vapor pressure of each components of solution is directly proportional to its mole fraction present in solution. Again for component first, according to the Raoult's law, this is the partial pressure of component 1 is directly proportional to mole fraction of component 1. Again, if be the ignore the proportional, so just be 1 the constant also, and P1 is equal to P1 naught x1, where the P1 naught is the vapor pressure of your component 1 at the same temperature. That's mean कि जो temperature आपका लिया गया था उसी same temperature में. And next one, and this is the for component 2, and P2 is proportional to x2. P2 is proportional to x2, and P2 also P2 is equal to P2 naught x2. P2 naught is equal to vapor pressure of the pure component 2. This is the P2 vapor pressure of the pure component 2. This is the vapor of pure component 2. Well understand. According to Dalton's law of partial pressure, आपने देखा होगा कि डाल्टन ने बोला है कि जो टोटल प्रेशर होता है वो सभी गैसेस के पार्शियल प्रेशर के सम के बराबर होता है. तो हियर वी कंसीडर कि P total is equal to P1 plus P2, and we know that कि P1 is equal to P1 naught x1, where the x1 is the mole fraction of component 1, and P2 is equal P2 naught x2. x1 is equal to 1 minus x2. Be right here, because the mole fraction is the sum of all the components is equal to that is the mole fraction of all components is equal to 1. So x1 is understand, because here is the only two components. So first is the x1, second is the x2. So next is the x1 is equal to 1 minus x2. We can write here, and here we open the bracket. So P1 naught into 1 is equal to P1 naught minus P1 naught x2 plus P2 naught x2. Okay, here x2 is the common, so we take the common x2. Okay, and here the P2 is here is the P2 is the positive, so P2 already written here, right here. So P2 naught minus P1 naught x2. This is the formula. Find out the total pressure of the volatile solution with the help of the partial pressure of the component 1 and mole fraction of component 2, and also the partial pressure of component 2. And what is the conclusion of this statement here? First conclusion है कि total vapor pressure is relates, अगर जो आपका टोटल वेपर प्रेशर होता है वो किससे रिलेट करता है, मोल फ्रैक्शन ऑफ एनी वन कंपोनेंट. कोई भी एक कंपोनेंट हो उसके मोल फ्रैक्शन पे डिपेंड करता है. अगेन टोटल वेपर प्रेशर वेरीज लिनियरली विद x2, वो एक ही कंपोनेंट के मोल फ्रैक्शंस पे वेरीज करता है. एंड अगेन P total of that is the total pressure of the solution decrease or increase with the increase of the mole fraction of component. Okay, कोई भी कंपोनेंट अगर इंक्रीज करता है तो उस पर प्रेशर डिक्रीज और इंक्रीज करता है. एंड कंपोनेंट 1 मीन्स क्या होता है कि कंपोनेंट 1 की क्वालिटी पे डिपेंड करता है कि वो कंपोनेंट कैसा लिया गया.